Okay, so in 10.6, we're looking at the volume of cones and pyramids. And so when we do these, first off, the basic formula for volume is very similar to that of a prism and a cylinder. And so our theorem 10.6 says the volume of a pyramid is simply going to be 1/3 the area of the base times the height. And so B is going to be the area of base. And then H is the distance from base to the vertex. Okay, and the idea of this H is going to be super important because you need to make sure you distinguish it between L, which is our lateral height again, and then also lateral edge if we have any problems that involve lateral edge as well. All right, so looking at a couple just quick examples about how to apply this formula. We look at number one. Now, on these problems, it doesn't tell you specifically that these are square bases. Assume, unless you're given reason to think otherwise, that these are going to be regular bases. Now, you can have things like rectangles, and especially with volume as your bases. They don't have to just be squares for you to be able to solve it. But for these problems, they are going to be squares. So number one is a really straightforward example of it. On that one, you have to look at it and say, do I know the area of the base? Well, yeah, you're actually given the area of the base is 400. And then your height, does this represent the height? Yeah, it represents the height because this from this point down to this point, we've got it at a right angle, which is how you measure the distance from a point to a plane, is that it's got to hit the plane at a right angle. And so that is the height. And so it's just going to be simply 1/3 times 400 times 36. So when you multiply that out, you end up with 4,800. In this case, it would be yards cubed. So you got 4,800 cubic yards in this pyramid. Just multiplying 1/3 times 400 times 36. Clearly, I multiplied the 1/3 times 36 first, and then did 12 times 400. For number two, when you take a look at this one, you have you're given 13, but 13 is not the height. 13 is the slant height. And as long as these are what we refer to as non-oblique or square pyramids, this point is going to be directly above the center of the base. If it's not directly above the center of the base, it's a harder problem to solve. And a lot of times that you can't do it in a straightforward way. But again, unless you're given information otherwise, assume it's right over the center of the base. So if we think about the center of the base, the distance from here to here is just going to be half, or as we refer to in a regular polygon, the apothem. And so you get this triangle, and the triangle is the apothem of the base, the lateral height of the base, of one of the faces, and then the height of the pyramid. So in this case, for this particular problem, you have it that it looks like this, where you have a 5 for the apothem. That comes from taking half of 10, this length right here. And then 13. And so what's the H going to be? Well, use your Pythagorean theorem, use your Pythagorean triples, and you can find that H is 12. So the volume is just going to be 1/3 the area of the base. Well, the base is a 10 by 10, so 100 times 12. And so it turns out to just be 400. So this is a case where you weren't given the height. You had to use Pythagorean theorem to find the height with your laterals. Okay, 3, this is what's referred to as an oblique pyramid. With oblique pyramids, it's really nice. They look complicated. Certainly the faces, finding the surface area of this would be very hard because each of those triangles are not the same like these first two problems, and so finding it would be difficult. But volume is actually very easy. It's just the exact same thing as if the center was right above it. As long as you know the distance from this point to the plane the base is on, which is what this is telling us, we can just apply the formula directly. 1/3 times 64 times 18, which turns out to be 384. So it's a very straightforward, easy way. Don't get caught up in the fact that it's leaning over, it does actually turn out to be exactly the same as if it was right above it, just for volume. All right, and then the last one, sometimes you might have to do some algebra. We know that volume equals 126, and we also know that volume is 1/3 the area of the base times the height. You're given the height, right? The height is 14. You need to find the base. Well, the base is just going to be 1/2 times 9 times x, because that's a right triangle. And so now we just need to go through and solve this for x. We got 1/2 times 14 would be 7. 1/3 times 9 is 3. So that gets us 126 equals 21x. Divide both sides by 21, and you get x equals 6. And so x equals 6 gives you the other side of this base. All right, then the other formula is going to be the volume of a cone. And so this is Theorem 10.9. And again, it is very similar to the volume of a pyramid in that it is 1/3 the area of the base times the height. So it's the exact same formula. But when you're talking about a cone, we actually know how to find the volume of the base all the time because it's just a circle. So it turns out to just be 1/3 times pi r squared, and then again times your h. So very similar type formula as a pyramid. These problems are much easier because there's not as many parts to it as the pyramids are. So you're just going to say the volume equals 1/3 pi r squared. So pi times, well, this 10 represents the diameter. So the radius is 5. So you're going to have 5 squared. And then your h is 12. And so that turns out to just give you 100 pi when you multiply that together. 1/3 times 12 is 4. 25 pi. 4 times 25 pi is 100. For 6, this is kind of like the one above where we're given the slant height. 17 is not the slant height. 15 is the actual height. Note, this is a little bit different, and you could have the same thing in a pyramid. Right up here, you were given the base and the slant height. This one, you're given the height and the slant height. So we still do our right triangle, but when we find it, what we end up finding using Pythagorean theorem, or Pythagorean, if you know your Pythagorean triple 8, 15, 17, you can find out that's 8. You actually get the radius of the circle using Pythagorean theorem. So you get volume equals 1/3, radius is 8, so 64 pi is the area of the base, 8 squared pi, times the height, which was given to you as 15. And so that turns out to be 320 pi. And finally, just like in the last problem, you can have what we refer to as an oblique cone, which is when the center is not the center, the vertex, the highest point of the cone is not above the center of the cone. And so you do volume equals 1/3 pi. The radius, well, this would represent the diameter. And so it's going to be 1/3 times 3 squared, and then just times 2. So very straightforward, and so you get 6 pi as your volume for this particular problem.